Done. Hey everyone, my name is Fraser Cain. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for March 28th, 2014. Today we are going to be talking about an asteroid with two rings, a new object discovered in the Kuiper Belt, or maybe the Oort Cloud. Update on Curiosity's wheel damage. We're going to do a recap of Cosmos. Messier marathoning, how to be an amateur radio astronomer, and we've got a special guest this week. We've got Dr. Alan Stern, the principal investigator of the New Horizons spacecraft, which, of course, as you may or may not know, is going to Pluto. And Alan Stern is also the founder of Uwingu. Hey, Alan, how's it going?
Hey, how's it going, Fraser?
We've got Dave Dickinson, a.k.a.
Hey.
Astro Guys, and some Messier...
I know. It looks like Klingon probably. I'm suffering through my afternoon bandwidth there. So.
We got Morgan Renberg. Hey, Morgan.
Hey, Fraser.
Now, and also, just to remind everybody, at the end of this episode of the Weekly Space Hangout, Morgan will take this conversation to the space community on Google+, and he will answer your questions about space and astronomy. Perhaps the stuff we talk about today, or really anything you want. Feel free to break his brain, ask him anything you want. Why is there something and not nothing? That kind of stuff. I love to see questions get asked. So great. Well, let's get on with them. I know, Alan, you've only got a few minutes, so and I'm really glad you're able to join us. Let's chat a bit for sort of what's going on with you, and then I know you can stick around and talk about some of the discoveries that you're interested in, or if you got a book, we totally understand. So. And I know you've got some interesting stuff that's happening with Uwingu, and I guess for those who don't know what Uwingu is, can you give us sort of an update?
Yeah, absolutely. Well, first of all, Uwingu is a little company that some astronomers and planetary scientists like myself formed a couple of years ago. We did an Indiegogo campaign to capitalize the company, and what we're all about is public engagement. It's a for-profit company that uses public engagement to generate funds. We call the Uwingu Fund, to make grants to space researchers and space educators, to organizations like International Dark Sky Association, Astronomers Without Borders, SETI Institute, things like that, to provide new ways to fund space research and education. We think it's cool.
Yeah, I keep saying Uwingu, but it is Uwingu, right?
It's Uwingu. It's a Swahili word. It means
That's right. And so what is sort of, I mean, I know you had some updates that you wanted to give, so what's sort of, I mean, we've had you on the show before, and of course we've reported on you quite a bit with Universe Today, and so what's kind of your latest news? Where are you at now?
Well, just a few weeks ago, just at the beginning of the month really, we launched something really new and really cool. We have our new map of Mars, in which we've ingested almost 600,000 scientifically cataloged craters, and anybody, anywhere who has access to the internet, anyone can go to our website, which is really simple. It's just, hope you can read it, www.uwingu.com. Just go there and engage in naming craters on Mars. And the coolest thing about it is you're not only helping to generate funds for space researchers and space educators, but we have a partnership with the Mars One private Mars mission, landing a robotic lander on Mars in 2018, and they're carrying our map to Mars with your names on it. So we found people really like this. We've had people from over 80 countries name almost 10,000 craters in just the month of March. By comparison, committees of astronomers like myself only named about 1,000 craters in the last 50 years. So crowdsourcing is working. We're challenging people to name more and more places on Mars, and they're humanizing the planet for the first time. There are memorials. There's a cool story on Facebook about a guy who proposed to his girlfriend. He says, "Hey, I'd name a crater on Mars. Check it out." And she goes over there, clicks on it, and the crater's called "Will You Marry Me?"
Will it remain that way?
Yeah.
Now I know that you've sort of gotten into a bit of controversy in the last month or so. I know the IAU, the International Astronomical Union, has taken sort of an official stance on sort of the naming objects in space. So what have they said?
So, they're a little bit the International Stuffed Shirt Union. They don't believe anybody except committees of IAU astronomers should name anything anywhere in space. So they're pissed about Uwingu. But then again, they wouldn't put the names of that the Apollo astronauts put at their landing sites for craters on official maps either. So we think we're creating a better map. It's got more features identified. It's more democratic because anybody can be involved. It's not done in the behind a closed door. And we're a little surprised they're upset, but as long as they're spelling our name right, it's driving public engagement and it's driving the Uwingu Fund. So we're all for it.
But I mean, there are a lot of like name a star companies that I've railed against quite a lot and written a lot of pretty aggressive debunking articles on Universe Today, and I've done videos about it. And so, what distinguishes what you're doing from what the name a star type people, which they're just coming up with a database. They're just naming the name, and no money's going to science. So it's that for entertainment purposes only, I guess. But it's quite frustrating when people think that their stars are getting named. So, what distinguishes you from those kinds of organizations?
This. Let's see if we can do it so people can read it. Maybe not, but just what you said. This is our tagline: name a crater and make an impact of your own. You're helping to fuel space research and education at Uwingu. We're doing public good.
Right, and so can you explain sort of how the money goes from the donations that you're receiving to the kinds of projects? What kinds of projects are you helping to fund?
Sure, absolutely. Yeah, so we try to run the company on half of everything we take in and give the other half to our Uwingu Fund for grants. So as dollars go in, our business person splits them out 50-50, and we squeeze all of our internet costs, our development costs, all of, taxes, all the things we have to pay for into the other half. And then every week we give a small Uwingu Fund grant. And as the numbers build, we hope to be giving grants daily and maybe even more often than that. But so far, Students for the Exploration and Development of Space, just in the last couple weeks, the SETI Fund, you know about that, the Search for Extraterrestrial Intelligence, Astronomers Without Borders, Explore Mars and Humans to Mars meeting that's coming up in April in Washington, D.C. We're just about to announce, and I'll break the news here, coming out in just the next couple of weeks will be an open competition for PhD students who want travel funds to go and present their PhD research at scientific meetings in planetary science or extrasolar planets. And we look forward to the day when we have $1 million in the Uwingu Fund and can call for the same kind of grant proposals that NASA and the National Science Foundation do so that we can be a real force for good. That's what we're doing this for.
I mean, do you see, we all experience it as journalists, as writers in this field, how much kind of public demand there is for the exploration of space, and yet it sort of chokes into these grant folks, NASA, National Science Foundation. Do you see this, what do you see as the future for science funding?
Well, I'll tell you, I spent some time at NASA headquarters. I was in charge of the science program there. I was the associate administrator in charge of all the science programs, planetary science, astrophysics, earth science, and I felt bad when we had to make a cut in something because the Office of Management and Budget or somebody up on Capitol Hill cut our budget. And what I realized is that unlike a lot of other areas, like if you're in energy research, you don't just go to the Department of Energy to be a researcher. There are energy companies, and there are multiple federal agencies you can go to. Same if you're in atmospheric research or medical research. Think about that. But in space, we kind of only own one stock. It's NASA. And if you only own one stock, you sort of deserve what you get when it goes down. So there's that bumper sticker that says, think globally, but act locally. And that's what we're doing in Uwingu, is we're starting one example of how we can diversify the funding landscape for researchers and educators that currently don't have anywhere else to go. And frankly, when all the craters on our Mars map have names, we'll have $10 million in the Uwingu Fund, and that's going to change the world a little.
Now, can you see a demand to more directly connect the donations and what people are naming with the kinds of things that are being discovered? I mean, you know, I can see that if you've got this sort of pool of funds that's coming together, and then that money is going to various projects allocated by whatever mechanism, it's like one step removed from people funding, say, extrasolar planet research, and then as the planets are discovered, the money going to them. I mean, can you see a more direct connection in the future?
Well, one of the things we want to do when we have more wheelbase is let people steer their money. So with the radio buttons, for example, you could click on, I want to fund Mars research or Kuiper Belt research or search for extraterrestrial intelligence. And then we're going to have review panels. In fact, our first one is for these student travel grants, just like you would at a federal agency, of experts to select the very best incoming proposals for funding. But one idea we have, which we think will really be a game changer, is instead of funding specific projects, we're going to fund people. We're going to fund researchers and take them out of this very inefficient system where they have to write a lot of proposals. So we'll say, Dr. So-and-so, tell us what you've been doing. And if they're doing good work and they've got a good track record, we're just going to send them money that would support them for the summer or for the year to do more good work without them having to write a big proposal about a specific idea. We want to unleash people to be creative in science and science education, particularly space science education, so we can get more mileage and make more discoveries and impact more kids.
Mm-hmm. Okay, well, let's shift gears. I mean, just one last reminder, I guess. Why don't you hold up your piece of paper just so people know where they can go?
www.uwingu.com. This is what the website looks like. And come over and help us name some craters on our Mars map, and then you'll know that your names are going to Mars, and you can Facebook share it, you can tweet it. There are little buttons there for almost every kind of social media you can think about. Tell your friends about it, and let's get a viral wave going.
So I'd like to shift gears then and talk about New Horizons. You've got the spacecraft behind you, which I thought it would be on its way to Pluto, but if it's going to be behind you, that's fine. But how's the spacecraft doing, and sort of where are we at on the mission? I mean, we're getting so close.
Yeah, we are close. You know, we launched this in 2006, and we get there next year. And we have to travel 32 astronomical units from the Earth to Pluto. It's 32 times as far as the Sun is from the Earth. And the analogy I like to use in public talks is, instead of thinking of these giant distances of 93 million miles per unit, think of it as a trip down your street, down the block. We have to go 32 houses. Well, so far, New Horizons has covered 29 of those houses, and we've only got 4 to go. We'll be there in July of 2015, and we are going to blow people's doors off exploring the Kuiper Belt.
We're going to, pretty soon, the images coming from New Horizons are going to be better than what's done from, say, the Hubble Space Telescope, right?
About a year from now, they'll exceed what the Hubble can do. We have much smaller telescopes than the Hubble, but we're going to be much closer range. So beginning around April of next year, we have what NASA calls BTH, better than Hubble. And that lasts for about 20 weeks on the approach, and then as we recede from the Pluto system.
Oh, that's really
so
exciting.
It's Pluto eye candy all the way through April through August of next year.
It's amazing. Oh, go ahead, David.
Have they found any secondary targets after Pluto and Charon for New Horizons at all yet?
Not yet. We have been looking using the Keck and Gemini and Subaru, the biggest telescopes in the world. We found about 50 KBOs behind Pluto, but none of them yet are within our fuel reach. We've applied to the Hubble Space Telescope to get time. We got turned down. We're hoping that gets reversed, because we really need the Hubble. We've had too much bad weather, and we're kind of running out of time before the Pluto flyby when we need to fire our engines. So stay tuned. We're hoping to make those discoveries in the next 12 months.
Like, you'll use the gravity of Pluto for an assist to help your new direction, right? No?
Actually not. And the reason is, we've designed the Pluto encounter and the geometry of that encounter and where our closest approach point is to deliver the most science on Pluto and its satellites, rather than concentrating on the Kuiper Belt object that we'll go to next. So we'll use our engines to do that, and that way we get the best of both worlds, which is a little bit of a pun.
Right. That's awesome. All right. Well, like I said, thanks again for taking the time to join us today. I know you've got just a couple of minutes left, and so why don't we transition into something that is sort of in your wheelhouse, and you can definitely sort of bring some additional knowledge, and then if you need to book after that, that would be great. So, Morgan, you've been working on this, which is that there's a new object out in the Kuiper Belt that's been discovered, perhaps from the Oort cloud. What's the deal?
Yeah, so traditionally we've thought of kind of breaking up the solar system into three parts. You have the planets. We're all familiar with the 8 planets of the solar system.
9.
Outside the planets, you
In fact, Morgan, not 9, but they're probably more like 900. That's
900. The 900 planets of the solar system. Yeah. Okay, Alan, we can't have the fight here.
outside the traditional 8 planets.
Don't make me get Neil deGrasse Tyson on the phone and bring him in here and let you
I'm
guys
calling
just
him
go
out
at it.
for a debate. We'll see if he'll do it.
Yeah, well, outside the traditional 8 planets, we have this region called the Kuiper Belt, which is 30 to 50 astronomical units away from the Sun. And then way, way, way outside that, we have this theorized big collection of objects called the Oort cloud. And that's tens of thousands, maybe, of astronomical units away, so much, much farther away than the planets or the Kuiper Belt. And for a long time, we've thought that the sort of in-between area is pretty empty. Not completely empty, but pretty empty. And we found the first object about 10 years ago from that region. And it's called Sedna. And it was curious because it has an incredibly elliptical or elongated orbit. It approaches as close as 76 AU from the Sun, but it can travel hundreds and hundreds of AU away on other parts of its orbit. And most orbits in the solar system are reasonably circular, so this was kind of an eye-opener. And for 10 years, that's pretty much all we had. But now we've discovered a second object that sort of fits in that same family. And right now it has the pretty ugly name of 2012 VP-113. And it has that name because it was labeled an asteroid in the Minor Planet Center before we figured out what it actually was. And it's even further away than Sedna is. So it's kind of a tricky thing to say because it doesn't get as far away at maximum distance from the Sun, but its minimum distance from the Sun, what we call perihelion, is farther away from our Sun than any other object we've ever discovered in our solar system. And that's about 80 astronomical units away. And so we've only seen it for a little bit. We only have a little part of its orbit, but we can reconstruct that to see the whole orbit that it would take over a period of several hundred years, and that would go from about 80 astronomical units to out to about 400. And so it's another one of these very elliptical objects, but now we have 2 elliptical objects in this region of space that we would have otherwise thought should be probably pretty empty, and if it did have things in it, we'd expect them to be more regular than what we're seeing here.
Alan, what do you think?
Yeah, well, we've known about the Oort cloud since the 50s, and we've seen objects from the Oort cloud many times. The long-period comets are all from the Oort cloud, and they all trace their orbits back to that place. The difference now, let me make an analogy. We had not been able to detect objects at the inner edge of the cloud. It was beyond our technology. So we could see objects dislodged from the cloud that would come close, but we couldn't see them when they were there. It's sort of like if you were living in the United States and you'd met people who came from France, but you'd never actually been to France and seen France. And now you have the technology to really see the other country. And what we're discovering is that the Oort cloud not only is populated with small guys like comets, but big guys like Sedna and like VP-113 that are dwarf planets. They have all the characteristics of planets. And what I expect we'll find later is Mars-sized objects and even larger objects in the Oort cloud because we have very strong forensic evidence from our own inner solar system region where the classical planets are that there used to be many more planets during the formation era, and most of them got ejected out to the Oort cloud, including some Earth-sized guys. And I'll give you one piece of evidence for that. Uranus, which weighs 15 times what the Earth does, is tipped on its side. And that didn't just happen. It happened because of a collision with something of 2 to 5 Earth masses. And in order for the probability of that impact to be high, you had to have a lot of 2 to 5 Earth mass guys around originally for one of them to strike Uranus. Where'd they go? The answer is the Oort cloud. It's the solar system's attic, and we're going to find all kinds of relics of the formation era. I think what Morgan's talking about is super exciting, and it's just the beginning.
I mean, I've heard that there are, some of the orbits of the some of the Kuiper Belt objects may predict that there is either a Mars-sized object a ways out, or maybe even a Neptune-sized object much further out that's influencing their orbital behavior, and that's a way that perhaps we can tease out the location and maybe even size of some of these objects further out.
Right, exactly, and it may point us where to put the infrared surveys of the future that could detect these big objects. They're very faint in reflected light, but they may have enough heat to be detected by infrared sensors. And so, but we have to know where in this big sky to look for these very faint targets. And what a discovery that'll be when we discover an Earth-sized object out there, or even a Mars-sized object. How is that going to transform our view of what the original solar system was really all about? The number of planets, and what really dominates the population of planets? Probably it's the Oort cloud planets.
Yeah, and so to get an object with this kind of a eccentric orbit, I mean, it goes from, 80 astronomical units out to 450 astronomical units. That had to be some kind of interaction with some other object, probably high mass, right, to get into that kind of...
The standard theory for this that the dynamicists have is that this object was probably born among the classical planets and ejected by an accidental close flyby of Jupiter, Saturn, Uranus, or Neptune. And so then it had this maximum distance of about 450. And then something else came along, maybe out in the Oort cloud, maybe a passing star, and lifted its perihelion from the giant planet region out into the Oort cloud, where it became detached from perturbations and in a frozen orbit that could exist there for billions of years. So now it's unconnected to its birthplace down among the giant planets and orbiting only in the Oort cloud. And that's what we see with most of the comets as well.
It sounds like the fact that it's near perihelion is the reason we found it at all.
Probably so, David.
Yeah.
It's because it's near perihelion, it's easiest to detect. So think, if we can only detect them at perihelion and we found a couple without looking very hard, what are the gear ratios for how many there really are out there?
What's not near perihelion? Yeah, and figuring they spend most of their time away from perihelion.
Absolutely.
They move slower when they're further out. So yeah.
That's why I say don't think 9, think 900.
Right.
Did they have a rough mass on this one right now? I know there's nothing orbiting it or anything yet that we know of. But.
It's a very small fraction of the mass of the Earth's moon. I believe it's about 450 kilometers across. That's about 300 miles. So this is a mini planet the size of a western state.
Yeah, something Mars or bigger size would be really interesting.
Oh, absolutely.
Even if we hadn't seen these two guys, Sedna and VP-113, it's not that unreasonable to think that we'd see Mars or Earth-sized objects out there, because we've seen them in extrasolar planets. We've seen, systems of extrasolar planets that extend a lot farther out than our traditional notion of the solar system does. And there's no reason to think the Earth is anomalous from that. It's just that, as Alan said, until now we haven't had the capability of detecting these things, and now that we do, we're going to start to pile them up just like we're piling up exoplanets.
I'd like to say, I think the Kuiper Belt and the Oort cloud are really changing the paradigm. We used to think the solar system was small and compact. It's actually enormous compared to the distance out to Neptune. The Oort cloud goes out more than 100 times further. And we're going to discover that there weren't just a small countable number of planets, but a very large number, and most of them aren't going to be what we thought were the norm, like the 4 giants or the 4 terrestrials. It's the Oort cloud and Kuiper Belt planets that probably dominate. And think about it, up until the 90s, we had no inkling of this. It's completely upending our view of the census of the solar system.
So, do you think that a significant portion of the mass of the solar system is out in the Oort cloud?
Yeah, in fact, the dynamicists have estimated that somewhere between 10 and 100 Earth masses of solid bodies are out there.
Wow.
Think about that. That's more mass than in the cores of the giant planets, if that's right.
Wow. All right, well, let's move on. And Alan, we're halfway through the show, and I know you can only stick around for 30 minutes. So if you want to book,
fun. Thank you, guys.
Hey, once again, let's see your little.
Uwingu.
Is that
All right.
Thanks for asking.
is that spacecraft got a real RTG back there?
Yeah,
Powering
the
the
only one
office.
on
I
Earth.
hope not. I'm going to get cancer or something.
All right, well, thanks a lot, Alan. It was a real
Take
pleasure
care.
having you join us,
Have fun.
and keep us posted. We'll see you later.
Bye-bye.
Bye.
Okay, cool, David. So, it's time for a Messier Marathon.
Yes, it is. It's that time of year again. It's this weekend is the new moon past the March equinox, which means that is an optimal time to try to catch all the objects in the Messier catalog, all 109 or 110, however you dice it out, in one night. Most people catalog it by 110, but there's actually some controversies in the Messier catalog. So 109 to 110. I've done it before a few years ago. I've never been as successful in March in Florida. Seems to be we usually have bad weather here when I try to do it. The trick is that you have to try to get some objects like around Andromeda in that area early on, and then what you're doing is you're moving over and trying to catch the Orion Nebula, the area around the Orion Nebula, the Crab Nebula up in Taurus, and then a lot of the Messier objects are scattered into two main groups in the Virgo cluster, supercluster of galaxies up through Coma Berenices, and then up through when you're looking at the core of the galaxy in Sagittarius. Those are the morning objects. So it's kind of a trick where you've got a few you've got to grab right off the bat, then you can kind of slowly go through and start picking them off one by one. And in the morning, it's that mad rush again to try to get M30 and those objects toward the core of the galaxy, like at the very last minute before sunrise. So it is kind of fun and challenging to do. It kind of gets you out there to actually see everything in the Messier catalog, which a lot of people have never actually done. Like I said, there's some controversies in the catalog. M102 is that famous 1010 109 controversy where some historians will say that's a reobservation of M101 that Messier did in his catalog. There's another NGC object that people will take in place of M102. There's some controversy from his catalog exactly what he observed. There's even a double star. I think it's M40 in the catalog is actually a double star. The Messier catalog, it comprises all these deep sky objects, anything from diffuse nebula to globular clusters to open clusters to galaxies to planetary nebula. It's just basically a big hodgepodge of deep sky objects. But it was one of the first systematic catalogs that he made that around 1780, Charles Messier did. He was a prolific comet hunter, and he was inspired after seeing M1 and mistaking it for a comet he decided he would go around and start cataloging all these objects to say these little fuzzy comet-looking like objects in the eyepieces are not actually comets. So he took I believe it was about 15 years to actually compile the first. He did several revisions to the catalog, and then over the years, people have looked back at his notes and then puzzled over what he actually observed. That's where there's even been some controversy for some objects, but it's kind of fun. Some people will try to sketch all the Messier objects. Some people will try to photograph all the Messier objects. I've seen people, you can get them all with binoculars if you get a pretty good set of binoculars in a dark sky sight. So it's kind of a fun challenge, and it works this time of year because the sun is off in the constellation Pisces right near that equinoctial point that it just passed on the equinox. It's off the plane of the galaxy, and it's not in the direction of no Messier objects lie right along that right ascension direction right there. That's why it only works in late March. And it's dependent on latitude, too. The article we did actually did a chart. A friend of mine did a chart, and I actually published it for him, that showed the dates by latitude when you would be able to theoretically get 109 and 110 objects from your particular latitude. It opens up right around this time for southern latitudes, like I'm 28 degrees north, and then it opens up successively the further. Messier made this catalog from Paris, so there's no Messier objects in the deep southern hemisphere.
Right.
The furthest, there's some just below the southern equator. The furthest southern one is Ptolemy's cluster I believe that's M8 down in Sagittarius. Is a Sagittarius or Scorpius, I believe. Yeah, it's in Scorpius. It's right down below. It's the furthest, most southern Messier object that he could get from his location. So he totally missed things like the Omega Centauri, all the large Messier.
The Magellanic Clouds.
He missed all that because he couldn't see that from Paris. You know, it is odd. He included the Pleiades, which, I mean, even in the worst optics, does not look comet-like. but he didn't include the double cluster in Perseus, which is actually quite a magnificent. There is some things that if you could go back, it would be curious to know what his thinking was. Did he just include M45, the Pleiades, to complete the catalog, or what the deal was with that? It's interesting.
So how many times have you done the marathon successfully?
I've done it once from Arizona. I think it was back in 2005. And some people just pick them off through the year and they get their certificate saying, and then you could go on with the IC and the NGC catalogs. I don't think you could do the NGC catalog in one night. I think it's too large.
No, it's thousands.
Yeah, but it's...
Maybe the virtual star party could do it in one night.
It would, I've thought about doing even the Messier Marathon. We would need well-placed scopes with clear skies at different longitudes.
Yes.
And you probably could do it in a couple hours. 1 hour, I think, for 110 objects you'd be going too quick.
Yeah, I mean, I've been thinking about it, and I know Michael Jobin here is like, will VSP do the Messier Marathon? I mean, if we had someone in England to capture that early stuff, and then someone on the east coast of the U.S., and then people in the mid and the west coast.
You'd have to choreograph it. You'd have to say who's gonna get these because like I said, there's a few tough objects at dawn and a few tough objects at dusk that are really key, that if you don't get those, you don't get the entire thing.
Yeah, and so, specifically dawn, we would need somebody maybe even in Turkey. So anyway, it would be tough, and it's one of my dreams, and someday we will do a virtual star party Messier Marathon and get her done in a couple of hours.
2 or 3 hours. And just
I wonder how many of the objects we've actually seen in the VSP. I wouldn't be surprised if we've seen most of them.
Somebody could go back and catalog that, But
somebody could do that.
See if there are supernovas back there.
That sounds like a lot of work. Yeah, see if there's any supernovas. All right. So, Morgan, let's go on to the other big story. And this got really eclipsed, which was, everyone was talking about the new object in the outer solar system, and then also an asteroid with a couple of moons. Oh, sorry, a couple of rings, which is the coolest thing ever.
And maybe a couple of moons, too.
Maybe a couple of moons, too, yeah.
Yeah, so this is an asteroid whose name I don't remember, but it lies out by Uranus. So this is not in your traditional asteroid belt. And astronomers were trying to better understand the size and shape of this asteroid. And they were using a technique called occultation. And we actually were talking about occultations a couple of weeks ago on this show. And basically, with something small like an asteroid, what you do is you watch it block the light from a background star. And then the shape and the size of the light curve that you get, seeing how bright that star looks as it blocks it, gives you information about the size and the shape of the occulting object, in this case the asteroid. But what they noticed in this observation wasn't that you just got one uniform dip, which is how it usually works, but they got 3 distinct dips, the main dip, and then 2 little dips on either side. And what that was a ring. In fact, it was two individual and discrete rings around this asteroid. And this is the first time that a ring has been discovered about an object that isn't a planet. We know of 4 ring systems in the solar system. Those around Jupiter, Saturn, Uranus, and Neptune. Of course, Saturn's far outshines everyone else's, but all the giant planets have ring systems, but none of the inner planets do. And we've been looking for ring systems around Pluto with no success using the Hubble Space Telescope. That's a special interest to New Horizons because whacking into a ring system would be a pretty quick way to end your mission. But this is the first time we found one that isn't around a giant planet. And there's a couple of interesting things about this ring system. When you have a ring system, usually one of 2 things happens. Either it clumps together and forms a moon. And that's what happened at the Earth. So when our moon formed, the most likely scenario for that is that a big Mars-sized body smashed into the Earth, and it would have created a ring around the Earth. But that ring would have quickly, over the course of just maybe tens of years, would have clumped together into what we see as the moon today. The other option is that usually happens is that the rings spread out, and they become very faint and very diffuse. And that's what we see at Jupiter or Uranus or Neptune. These are very thin, very faint rings. But the rings that we're seeing around this asteroid are actually quite dense, and they almost better resemble Saturn's rings than any of the other rings in the solar system. And really the only way to get that, especially with these thin rings, is to have what are called shepherd moons. And these are little moons that orbit on each side of the ring, and they use their gravitational influence to combine or to constrain this ring material. And to constrain a ring, you need 2 moons, one on each. And so if you have 2 rings, there could be maybe even 4 moons about this asteroid, in addition to the 2 rings. And they probably all formed out of some initial impact that maybe is the source of why this asteroid is so far out and not in the main asteroid belt.
And so, I mean, if there's one that's been discovered, that means there's going to be zillions out there that you know, we just got to wait for more occultations and look for more situations where they're going to end up with a moon. But I never expected that there would be a ring system around an asteroid.
No, I mean, if it can happen once, it'll happen again, because there's millions of asteroids out there. And it's been a pretty good year for asteroids. You consider we saw that asteroid, Ceres maybe venting material. We saw that asteroid with like 7 tails recently, and now we have an asteroid with rings. I think that this sort of follows up with what Alan was saying earlier, which is we used to think about studying the solar system as studying the 8 or 9 planets and their accompanying moons. But now we're understanding that the asteroids and the comets and the Kuiper Belt objects and the Oort cloud objects are just as dynamic and just as interesting objects to study as these big planets. They're just more difficult, and until now we haven't had the technology to do it.
Fantastic. Okay, so let's move on. Now, you watched Cosmos the third episode of Cosmos, Morgan. Did you watch it, David?
Yes, I did. I watched it Monday on Hulu.
I also watched it, so we can have a meaningful conversation about it. So, all right. So, Morgan, what'd you think?
I liked it. I'm kind of a history buff, though, and I can understand some people maybe didn't like it as much because it was a little more historical, a little less, pretty. But I really liked how we highlighted someone who is kind of an unsung hero in the early days of science, because
for people who haven't watched it yet, I mean, the whole episode was about who? About
Edmund Halley.
Yeah. And
Halley was a member of the Royal Society, which was the main British scientific body at the time. And while he had a lot of really important contributions for science on his own, his biggest contribution was sort of as the taskmaster for Isaac Newton. And today we see Newton as the founder of science. Modern science derives from the works of Isaac Newton, specifically the Principia Mathematica, which was the first modern science work, and it laid out the basic laws of physics. And from those laws, many of which we still use to navigate spacecraft and rockets and things today, but from those laws, all of science basically unfolded. But Newton was a pretty eccentric guy, and he wouldn't have actually bothered to write this stuff down if Halley hadn't been riding on his back. And that's something that we often overlook. But without Edmund Halley, all these amazing contributions from Newton and others just never would have seen the light of day.
David, what'd you think?
I thought it was kind of interesting that they actually hit one of my favorite historical footnotes, and maybe no one else would catch this, but me, since I read a lot of this kind of bizarre stuff, but that the Principia almost didn't get published because of the history of fishes, of all things. I thought it was actually kind of, it was like, that's cool they put that in there, because I'd heard that before, that the Royal Society had blown most of their money at that point on this lavish book that no one actually had no historical impact afterwards, no one had ever heard of, in one of the most historical books like in science ever, almost didn't get written because of that. And I just thought it was interesting that Cosmos, a lot of people kind of thought this episode was kind of ho-hum from what I've seen on Twitter. It was actually my favorite of the 3 thus far, but I like that boring history
I'm
stuff,
going to agree. This is so funny because it is also, I think, my favorite of the 3 as well, which is, and I guess partly because I'm always kind of just in the middle of all of this stuff all the time, and so I'm seeing all these animations, and I'm seeing, I know what Saturn is, and I know what, and I know some of that other stuff, and so in this case, it was a delve down into a very interesting story in history, and it was told quite well.
They dug a little deeper for even for us folks that read this kind of stuff. We know about Halley's Comet, we know about Newton and the laws of gravity, but they pulled out a few things that got me looking at Wikipedia and reading through. And I was like, I didn't know that. So,
yeah. And so my son was bored out of his brain and
I
turned
heard you guys
around
on
and
Astronomy
didn't want to
Cast
watch
on that.
anymore. And I was actually quite enthralled by the whole thing. It was mostly, I mean, there was like a little bit of Oort. Jan Oort in the beginning, but apart from that, it was like a huge chunk of it was on this story about Newton and Halley and Hook, evil Hook. I think they might have sort of gone a little overboard with making him look like a monster, but it was I thought it was really good, and I thought it was very brave, and I think it's going to utterly haunt them, because I think the feedback, as you said on Twitter, was fairly negative, and I think
it had a fair amount of meat to it, though. Like I said, more than just the usual, like just the surface stuff that you usually hear about Newton and the stuff that we hear repeated over and over and over again. So I thought it was a worthy effort.
This is the power, I think, that Cosmos has that none of these other series have. Is, you can turn on the History Channel or Science Channel or any of these other channels and see these animations and these, wonders of the solar system. But what's becoming increasingly clear to me is that Cosmos is setting out here to explain science, to explain how science works, why it works, and why we do it. And it's more interested in that than it is in taking a pretty tour through the solar system and highlighting the stuff we can see in the universe. And, ultimately, that's a far more valuable thing for it to do, is to try to give some people an idea of how scientists like Alan come up with these things. Because it looks like, we're all sitting around in lab coats somewhere on, Mount Science, handing down all of these ideas, but, where did it come from? And Cosmos is going to show us where it comes from, and that is the most valuable thing it could do.
Yeah, absolutely. So it's funny. I mean, I think, oh man, I feel terrible, but I suspect it's going to be a ratings flop at this point. Like I don't think that episode is going to really grip people. And I think a lot of people who were hoping to see, as you said, they were hoping to see amazing animation, amazing 3D animations, and the spaceship of imagination zipping around, and like just highlights, like let's watch a black hole form, let's watch a supernova go off, let's see the dawn of the universe, and now we're going into Saturn. Like that's what I think that people were sort of expecting to see, and instead you're getting these stories of scientific progress and things like that, and it feels a lot closer to something like Connections, or which is one of my favorite things. So
there's been a lot of discussion about whether it's just us space folks that are watching this, or if the general public is really watching it. But I did a local star party last Saturday night, and I had a few people asking me about things on the new Cosmos. So I think there's a little bleed through to just the general public is seeing it in paying attention. At least you could argue people that go to star parties are probably interested in space to begin with, but it's encouraging.
Yeah, and I hope that people recalibrate their brain and go, if you wanted to watch all that stuff, go watch the History Channel's The Universe or Wonders of the Solar System, and in this case, they're telling a different story, and it's interesting. So there is a lot of great big animation and Neil deGrasse Tyson's Gravitas and all that. So that's all there, and
it's still weird to see Cosmos with commercials. Anyway, I'm like, oh yeah, there's commercial break.
Right. Okay, well let's move on. David, you had a cool article this week about how to be an amateur radio astronomer.
Yeah,
I wish we had Nicole here, but we're gonna.
I wanted to track her down because she probably would have a little more of the technical information, because I'm an optical backyard astronomer guy. So it's when I started, Nancy pitched the idea to me, and I started digging into it and reading about it. I knew a little bit about radio meteors and what people were doing. I'd done some things with observing radios on the FM dial, but I didn't realize the extent that some people were going toward with actually constructing their own backyard radio telescopes and doing these ad hoc SETI searches, monitoring solar activity, tracking the ISS. I mean, there were even amateurs that caught the signal from the Chinese U2 rover on the moon a few lunar cycles ago when they thought it had died. It was amateur astronomers over in UK, I believe it was, that started catching the carrier wave signal from it. And this is from just their backyard ham radio sets that they were using. So I think it's pretty amazing what they're doing out there with radio astronomy. I actually want to dig into this some more. What I'd like to write next is an actual nuts and bolts constructing a radio telescope, like, the how-to from beginning to end. Either if somebody's done this or to do it myself. I mean, it would take a while to write it, but it's pretty incredible what people are doing out there with these things. And these are dishes like back in the days when everybody had satellite TV, and a lot of times people still have these dishes in their backyard. They can do actual radio astronomy with these things.
So like a big, like one of those big 8-inch dishes that you can just go and pick up at a garage sale, and you can set that up.
And some of them, I've seen some people online were doing, one person had what they called the little itty-bitty array. They were using a dish that was one of those little satellite TV dishes that you'd see outside an apartment. They were actually able to monitor solar activity on the sun and pick up things like the Jupiter Io flux tube and things like that. It's pretty incredible. You don't think that you could do that with just a little amateur setup, but people are doing it, and they're tracking the ISS, tracking geostationary satellites. It's pretty incredible.
That is really cool. And Morgan, your work is all in planetary science, so you took a course in it, right?
Yeah, so I sort of know a little bit about it, but for me, radio astronomy is sort of still on the magical end of science, and I'm actually really excited to try out some of these things and get a more. There's no better way, to understand something than to do it.
Yeah.
And to, if it's only going to cost me, a little bit of money on top of stuff I have laying around, then I'd love to try it out for myself.
Well, I've seen these dishes when I make a run to the local dump every month or so. I see some of these dishes sitting out there in the scrap pile. So
yeah, and are you just imagining them all in a big array?
I wonder what my housing association would say.
Array.
The Dave array.
A giant steerable array. Yeah, I wonder what the housing association would say.
The Dickinson array. I love it.
I just tell them it's for aliens, and they'd probably be like, "Oh, cool. That's crazy."
Can we watch? Yeah. All right. Well, let's move on. So, last story, and this should be a quick one. So, Morgan, how are Curiosity's wheels doing?
They're doing better than they were before. It turns out, maybe not a surprise to those of us who drive here on the Earth, that the safer you drive, the less likely you are to get in an accident. And that's basically what the takeaway from this is Curiosity's now been on Mars for about a year and a half. But it was building up damage to its wheels a lot more rapidly than they were expecting. And this damage is basically holes poked into the metal wheels that Curiosity drives on. And they figured out that the source of the vast majority of these pokes were when they were driving over this one particular kind of rock called capping stone. And it's just very hard, very pointy, sharp rocks that are on some of the features between the crater where Curiosity landed and Mount Sharp, where it's headed. And they figured out that it was far worth it to detour around these regions than to try to drive over them. Yeah, so here we can see a picture of the wheels of Curiosity, and you can imagine holes being poked into these treads. And the more holes you have, the more sand and stuff that can leak through. And so now, by steering around these obstacles, they've reduced the rate of buildup for these holes by a factor of 10. And so, 1/10 as many holes are appearing every day as before. And then, sort of parallel to this, they did a study where they took these wheels on a sister rover here on Earth, and they just, took a hatchet to them and just shredded them. And they were able to show that even with substantial chunks of these wheels missing, that they'd still perform adequately to support the rover and to allow enough traction to drive. And so overall, the bottom line is, don't worry.
Don't panic.
These wheels are going to last longer than necessary, and as long as we're a little bit careful about where we drive, we're going to get there just fine and be fully operational.
Oh, that's awesome.
It's hard to imagine that someday Curiosity, most of these rovers, eventually they become just stationary observers.
Yeah, well, and that's the great thing about Curiosity above and beyond Opportunity and Spirit, is Spirit and Opportunity had solar panels. So as soon as they stop pointing at the sun, they lose power and they freeze and they die. That's what happened to U2. It's what happened to Spirit eventually. But Curiosity has an onboard nuclear power plant, basically.
Yeah.
And so she'll be able to operate stationary for years as a ground-based station and just basically be a weather station on Mars after her other scientific instruments stop working or we stop funding them.
I think that I was going to say, I think the funding will run out before Curiosity's RTG runs out.
Oh, absolutely.
Yeah, well, we look at the Voyager spacecraft; they're still going.
That's what happened with Viking. Actually,
Yeah.
they pulled the plug on the Vikings before the. Yeah.
I wonder if it's still going. Okay, well, so we've got a little time. I want to get a couple of questions, just because some people had asked a bunch of really neat questions. So Stuart Rosenberg asked, this is sort of about Uranus, and this, Alan's gone, but I know you could probably handle this, Morgan. Could the object that tilted Uranus be inside Uranus still, if it hit?
It's possible that it could be inside Uranus. We've never been to Uranus other than flying by once, and so we actually understand its internal structure very poorly. It's also possible that the collision wasn't necessarily a physical collision, but was a very close approach that had very strong gravitational effects. And so you can have these sort of collision-like interactions without actually having to physically touch. But the real answer is we don't know, because we haven't been close enough to Uranus for long enough to understand what its interior looks like.
But it's also, if a Mars-sized object smashed into the Earth and helped create the Moon, is that object still inside the Earth? Well,
a lot of it is. Yeah, a lot of it's part of the Earth, and a lot of it's part of the Moon.
Yeah. So, so yes, it was completely destroyed, and but it's not like it plunged in and sank down inside Uranus.
No, the atmosphere would have broken it up. It would have been a very bad day for this Mars-sized object.
Yeah, it would have been a bad day for the planet. It would have been a bad day for Uranus, enough to knock it over on its side. Okay, Richard Strassel asks, I wonder how stable the asteroid's rings are. How long have they been there, and how long will they last? So we're talking about the asteroid with its rings.
I'd have to say that, not knowing a lot at this point, we'd have to assume they've been there a pretty long time, because this asteroid is it's not in the asteroid belt, like I said. It's in a pretty empty region of space. You'd expect collisions very infrequently in these areas. And so if, in fact, these rings were created via a collision, then the likelihood that collision happened recently is quite low. But, in terms of giving millions or billions of years, we couldn't speculate too much on that. But I'd say longer rather than shorter.
Paul Gracie asks, I happen to have a 10-foot diameter dish in my backyard. What more would I need to add, and what could I detect? So, David, with a 10-foot diameter dish...
10 foot's pretty good size, actually. You definitely need, in the article I wrote, there's a bunch of links to some more technical detail, but there are programs now that you can download onto your laptop where you can actually turn it into a, you'd need the actual receiver and the oscillator and the amplifier to hook into it, but it will actually give you the readout and the monitoring, which is cool, because before computers and laptops back in the 60s and 70s, people were building dishes, but you needed that customized receiver on there. And what a lot of people are using, a lot of satellite dish installers used to have, and they probably could find a lot of these still, is the little gauge that when you're pointing the dish gives you the signal, just the signal gauge that actually shows it where it's pointing to, and that's pretty handy. I mean, you could probably rig up something to aim at the sun at least and get the solar flare signals off that pretty easy.
Now, if I recall correctly, when Pamela taught me in an episode of Astronomy Cast, it doesn't work like an optical telescope. Like with an optical telescope, you're capturing all these photons, you're magnifying them, and you're producing an image. But with a radio telescope, it's got a very tiny point of what its resolution is, and you're steering it across the sky, and you're measuring the amplitude of the radio signals as you're going past these objects, and you're kind of building up a picture with multiple passes, right?
The resolution is still pretty coarse. Yeah, so you're doing what's called drift scanning, is what they call it. Is where you're basically letting either the signal drift over you as the Earth rotates, or you're moving the dish like off axis and on axis to point it. So it's something I've never done personally, but it sounds pretty interesting. So I may be doing it.
Yeah, the most advanced radio telescopes in the world might have 24 pixels. Or something like that. It's a big step now beyond 1 pixel is what we were trying to get beyond for a long time, and now we've got a few pixels.
To increase resolution, and some amateurs have gotten into interferometry too, where they've linked up multiple dishes. That's what professionals are doing. Some of the interferometers they're using are the size of continents, where they're actually linking dishes. You can do that with the long radio wavelengths. It works pretty well, but you can link radio telescopes between Hawaii and Arizona and Bermuda and actually create the very long baseline array uses that.
Yeah, and so you've got to have the kind of mind that enjoys that kind of thing where you're literally building up an image pixel by pixel by very carefully measuring the readings, and make sure that you got your tracking in the right location and not, the pixel to the left one. Otherwise, you've got the wrong data.
That was something I found out this weekend too. Is that amateurs are actually doing radio interferometry too, which I had never realized.
Rich Hayward says the article I had read talked about a rogue planet or an ejected planet perturbing these inner Oort objects. Any opinions, Morgan?
Yeah, so I know that Phil Plait talked about that in his piece, and all we know at this point is that we have these very elongated objects, and we know that we see Earth-sized planets far out in solar systems around other stars, but this isn't like the case of using perturbations on Uranus to predict the location of Neptune, which is how Neptune was first discovered. We don't have enough information to do some sort of prediction like that. But we can't rule it out either, and it's a reasonably popular theory amongst those of us who sit around and speculate on those things. But we don't know more than that.
Adam Synergy says, will we be able to view New Horizons raw images online? Absolutely. When they start coming out, they'll go, typically the way NASA works with these things is they have a raw image server for every mission, and as soon as the images are captured, they go into this raw server, and they're usually made available to the public. In fact, we often, if we want to get the jump on our competitors, we will watch those directories, and as soon as those new images are dropped in, we will jump on them. We'll do our own image processing to try and sort of get something up on the website before NASA's had a chance. So absolutely, you will all get a chance to get access to these images, either if you want, directly off the server, or if you want to wait a little while with us.
And like we said before, us science writers will finally have some new, fresh images to illustrate our Pluto articles.
Oh,
it's going to be 150 days.
Yeah,
rather than the same 6 images and artist conceptions that we keep recycling.
Yeah. Cool. Okay, so why don't we wrap things up? Now, before we get on to where people can find out more, I just want to let you all know that we have set up the Weekly Space Hangout feed on iTunes and in RSS. And so if you've got a podcatching software and you only want either the video or the audio and you want it to show up on your portable device, you can now do that. Just do a search on iTunes for the Weekly Space Hangout. I think it's got the wrong icon. It's got the Universe Today icon. We're going to switch it to the proper one shortly, but it's just those episodes. It's just the video and the audio and 2 separate feeds so you can get what you want. And I know that for a lot of people, they prefer that than trying to watch it on YouTube or even watch it live. So that exists. So Dave Dickinson, where do we find out more?
This week I was active on listosaurcanada.com, Universe Today, and I am on my own Twitter feed as @AstroGuys and my own website at astroguys.com.
Sweet. Morgan, more.
Yeah, Morgan. I got a bunch this week. Let's see. I'll take your questions over on the Google Space Hangout, directly following this episode.
Yeah, in the space community. So go to Google,
Space
go
Community.
to community, click on Space, and you will see a thing there. And I think I can pin things.
I can pin it too. I'll
pin it too. Yes, go ahead and pin it. You have my permission, and then that'll keep it there for maybe the day.
Yeah, all right. You can catch the monthly news roundup tomorrow on CosmoQuest's 365 Days of Astronomy podcast. Let's see. A week from tomorrow, if you're in the Denver Boulder area, you can come by Fisk Planetarium. I'll be giving talks all afternoon as part of their Astronomy Day. So if you want to learn about all sorts of nifty things in the history of the universe, I'll be sharing some cool pictures and cool ideas. I'm on Twitter, or we're on Twitter. It's not just me, actually. I'm cosmic_chatter, and the website is cosmicchatter.org.
Right on. Okay, well, thanks, guys, and thanks to Alan who had to book out. Thanks to everybody watching. Once again, I'm the publisher of Universe Today. You can find out what I do over at universetoday.com, and we've been doing a lot of cool videos. We just wrapped up another week of shooting here in beautiful Courtney, British Columbia. So we got another 8 videos coming at you with some pretty crazy topics. So I hope you'll enjoy them. And we'll see you all. I think the next thing, I guess, is going to be hopefully the virtual star party, unless we all get rained out again. And we'll see you all. We'll see you all then. Otherwise, next week. Thanks, everyone.
Later.
Come on, stop broadcasting. I don't know. Is this still happening? Are people still seeing it?
Still live.
Yeah. Yeah, we're still live.
A look behind the scenes.
No. Yeah, what were the topics that we did this week? We did does light experience time? How far does gravity reach? How can we live on Mars? They're not going to let us stop.
I was just going to keep going.
It's just going to keep going. This episode must last forever. What else did we do? Where is the center of the universe? How far can you see into the universe? Why do galaxies have arms? And a bunch
You're
of
taking all the topics. What are the rest of us supposed to do?
We put out 2 a week. Try to keep up.
I'm lucky to write 2 things a week, much less 2 videos.
Yeah, it's tough. No, Nancy says we're still here. Nope. Okay, you know what? Then we should just close these windows. So everyone just shut down their window and that was
Sweet world.
All right. See y'all later.
See ya.
take this conversation to the space community on Google+, and he will answer your questions about space and astronomy. Perhaps the stuff we talk about today, or really anything you want. Feel free to break his brain, ask him anything you want. Why is there something and not nothing? That kind of stuff. I love to see these questions get asked. So great. Well, let's get on with that. I know, Alan, you've only got a few minutes, so and I'm really glad you're able to join us. Let's chat a bit for sort of what's going on with you, and then I know you can stick around and talk about some of the discoveries that you're interested in, or if you got a book, we totally understand. So. And I know you've got some interesting stuff that's happening with Uwingu, and I guess for those who don't know what Uwingu is, can you give us sort of an update?
Yeah, absolutely. Well, first of all, Uwingu is a little company that some astronomers and planetary scientists like myself formed a couple of years ago. We did an Indiegogo campaign to capitalize the company, and what we're all about is public engagement. It's a for-profit company that uses public engagement to generate funds. We call the Uwingu Fund, to make grants to space researchers and space educators, to organizations like International Dark Sky Association, Astronomers Without Borders, SETI Institute.
Done. Hey everyone, my name is Fraser Cain. I'm the publisher of Universe Today, and this is your Weekly Space Hangout for March 28th, 2014. Today we are going to be talking about an asteroid with 2 rings, a new object discovered in the Kuiper Belt, or maybe the Oort cloud. Update on Curiosity's wheel damage. We're going to do a recap of Cosmos. Messier marathoning, how to be an amateur radio astronomer, and we've got a special guest this week. We've got Dr. Alan Stern, the principal investigator of the New Horizons spacecraft, which, of course, as you may or may not know, is going to Pluto. And Alan Stern is also the founder of Uwingu. Hey, Alan, how's it going?
Hey, how's it going, Fraser?
We've got Dave Dickinson, a.k.a.
Hey.
Astro Guys, and some Messier...
I know. It looks like Klingon, probably. I'm suffering through my afternoon bandwidth there, so.
We got Morgan Renberg. Hey, Morgan.
Hey, Fraser.
Now, and also, just to remind everybody, at the end of this episode of the Weekly Space Hangout, Morgan will